Good evening, everybody. Thanks very much for joining us this evening. My name's Joe Gabbles. I'm Program Manager for Sheep and Goat Research and Development at Meat and Livestock Australia. We've got a great lineup of speakers to talk to you this evening on the topic of sustainable grazing management of rangeland goats. I'm just going to run through a little bit of housekeeping to start off with. Firstly, just to say that this session will be recorded and we'll be distributing it via the MLA YouTube channel on the Goats Hub after the session this evening. I do encourage you to put questions for our speakers into the Q&A box as we go through the sessions today. We'll have the opportunity to answer some of those as we go along, and then we'll have a live Q&A session at the end for any additional questions that we didn't get to. If we do have any connectivity issues, if the webinar is disconnected at any point, we'll send a new link out within 10 minutes. So fingers crossed that won't happen, but just in case that does happen, we'll send a new link through. So I'm just going to kick us off this evening by giving us a quick introduction into the MLA Goat program. So as I said, my name is Joe Gabbles. I'm based over in Perth in Western Australia, and I work closely with Melanie Smith, who's the project manager for Sheep and Goat Research and Development and is based out of our North Sydney office. So I just wanted to take you through a couple of key aspects related to the MLA Goat program today. One is I'm just going to touch on the industry structure and explain a little bit about how the levy system works. I'm going to focus then mostly on markets. Obviously, there's been a lot of interest in that space at the moment. I'll touch very briefly on R&D, and then we'll get into our lineup of panel speakers. So first off, this slide just really gives you an overview of MLA's role within industry. So MLA's role is very much as a service provider to industry, and we have two core pillars of activity. One is research, development and adoption projects, and the other is marketing and market access. So MLA isn't a policy organisation. We take leadership from the peak industry councils, which from the goat industry is the Goat Industry Council of Australia, or GICA. And GICA have a place on the Red Meat Advisory Panel as well, or RMAC, which is the overarching policy leadership group for the red meat industry in Australia. So GICA's key role is to develop collective goat industry policy across all breeds and production system types, and GICA work closely with government industry bodies like MLA, producers and also other peak industry councils. We also have GERDAC, which is the Goat Industry Research, Development and Adoption Committee. So this is an MLA managed committee whose key role is to provide advice on investment priorities to both MLA and GICA. It's comprised predominantly of producer members with a couple of other expert members as well. We do have an annual recruitment for 2 positions, and we'll be having our annual call in July for anybody who's interested in being involved in the position. And we do currently have one outstanding vacancy for a rangeland producer member. So just in terms of the goat levy is a transaction-based levy. So every time the ownership of a goat is transferred, a levy is applicable, and it's a total of 37.7 cents. So of that, MLA receives 16.7 cents for research and development activities, 10.5 cents go into marketing activities. Animal Health Australia receive 4.5 cents for animal health and welfare related research, and then there's the National Residue Survey, which gets the remaining 6 cents as well, and is a really critical aspect to underpinning some of our access to international markets. So from an MLA perspective, what that means is that we've got about $500,000 per year of goat levies to invest, and that's split roughly 300,000 in the research, development, adoption space, and the remaining 200,000 in the marketing and market access space. And it's fairly evenly split across our core investment pillars in terms of where that investment sits. Conscious that the rounding means that those numbers won't add up there. We also have the MLA Donor Company. So the MLA Donor Company is a subsidiary company of MLA, and really the focus of the MLA Donor Company is on attracting new investment into the red meat sector. So what this enables us to do is to take $1 of federal government funds and to match it with private partner investment into the industry to help us really leverage up and scale the level of investment that we can make. So we've got some good, exciting new projects in the goat space through the MLA Donor Company at the moment. So just going to focus a little bit on markets over the next few slides. So firstly, the graph that you can see on the screen in front of you is the Australian goat meat export volumes. And what we can see is that following the period of drought, which broke at the end of 2019, we've seen a quite rapid recovery in terms of supply. So numbers have gone up from about a low of 1.2 million or so in 2020, and we're now sitting around 1.7 or 1.8 million in the 2022 calendar year. In addition to the increase in numbers, we're also seeing an increase in carcass weights as well, which have gone from around 14 up to around 17 kilos today. So that's helping to push up those export volumes as well. And when we look in terms of where that supply, where that goat meat is going, traditionally we've been very focused on the international markets, with sort of 90–95% of all production being exported. But over the last 12 months, there has been quite an uptick in the domestic market, which took 23% of production in 2022. And I think that's probably pretty much as high as it's ever been. So if we look at our key or top 5 export markets, we can see in the yellow there is the USA, which is by far and away the largest single export market, taking around 60% of total production. The next bar up in the dark green is South Korea, and that's been a market that's had really rapid growth in recent years, but is also one of our highest value markets as well. And then we've got Canada, Taiwan, Trinidad and Tobago, which make up the others in the top 5 markets. So a lot of you will be all too aware of the recent drop in goat prices, which have come back from around $9 a kilo in the middle of last year. And I believe in the last over the hooked indicator report, we're sitting somewhere around that 260, 280 per kilo. And I guess there's been a number of drivers of that price reduction. We've got a number of domestic factors, such as that really significant increase in supply that we've seen over the last 2 years. There's also been a similar sort of trend in terms of sheep numbers as well, which means that we're competing for fairly limited or limited processing capacity. So getting that throughput and getting goats into the process has been challenging for many. And we have a fairly limited, although growing, domestic market, as I touched on before. I think in terms of the international factors, really what happens in the USA is the thing that has the biggest impact. And what we've seen over there is a prolonged period of drought, which has resulted in increasing female cattle slaughter. So there are quite high protein inventories across the board. So for beef, for sheep meat, for goat, as well as other proteins as well. And goat being a fairly niche and one of the higher cost proteins in the market, there's a general downward pressure on protein prices in the US, and some generally tight economic conditions there as well. And then lastly, I've just got in there the sort of reliance on commodity markets with fairly limited product differentiation as well makes it a little bit more difficult in terms of competition there. So if we look ahead, I think the medium-term picture starts to look more promising. We will eventually see the drought conditions in the USA ease, which will in turn reduce the protein inventory that we've got over there. The upside of having lower prices is that some of those other international markets start to come back online. So we've seen increased interest in the Caribbean and Canada in particular, but also a couple of markets like Vietnam across Southern Asia. We've got a good already, but improving market access position to some of our high value markets like South Korea and Taiwan, which have had diminishing tariffs over a number of years now. And I think it's 2023, they both dropped to zero. There's also quite a lot of interest in the Australian Indian Economic Cooperation and Trade Agreement. And I hope that there may be some improved market access for goat meat into that market in the medium term as well. And as I said, I think there's still some good opportunities and some question marks around what the opportunity might be from a domestic market perspective as well. So in terms of gaps and opportunities, both from a sort of R&D, but also a marketing perspective, the stability of supply is still a major issue. We're seeing those major fluctuations. I think as we transition increasingly to more managed rangeland goats and rely less on the harvest industry, that will naturally help to improve that stability of supply, and with that enables us to be more consistent in terms of servicing some of those export markets and investing in further marketing there. The market insights team have indicated that there's an opportunity to get some more market insights from the Caribbean markets and just understand some of the consumer drivers in those markets in a bit more detail. And I think there's probably a good opportunity at the moment to start thinking about what are the longer term value chain development opportunities, which I think would include the domestic market as well. So from a research development and adoption perspective, and I'm going to be fairly brief on this section, but there's lots of information available on the MLA website as well. We've got 3 core priorities that are in our annual investment plan, which is available through the MLA website. The first of which is selection, breeding and management programs. So in essence, that's improving goat genetic performance, goat reproductive performance, and thinking about animal health and welfare management as well. The second priority is around goat industry sustainability. So, making sure that the goat industry is in a position to demonstrate its sustainability credentials alongside the beef and sheep sectors as well. And then thirdly, industry engagement, knowledge and capacity building. So we have a whole range of initiatives, including this webinar series that really aims to sort of help support knowledge building and sharing information across the industry as well. An initiative we launched last year is some small seed funding opportunities for both goat producer groups as well as individuals within the goat industry. So that might be advisors or students or individual producers. So the focus of this terms of reference is to provide small one-time grants for groups or for individuals, really focusing on training opportunities, supporting group formation activities, events and knowledge sharing. So really what we're looking for in these applications is to see what that clear value proposition is for the goat industry and that clear pathway to ongoing industry participation and impact. So we will be opening that call in the next couple of weeks. So I encourage you to keep an eye out on the MLA website and through our communication channels for that call, and hopefully we'll get some good applications for this round of funding. So I'm just going to pull up there. Thanks very much for listening to me and introduce our first external speaker of the evening. So our first speaker is Mark Trotter. Mark is Professor of Precision Livestock Management at Central Queensland University. And Mark's research is all about getting technology working on farms to improve production efficiency, either by increasing production and price or reducing costs. And Mark specialises in on-animal sensing and feed-based monitoring and management. So Mark's talk is entitled Spatially Resilient Grazing Systems and Goat Behaviour in the Landscape. I'll hand you over to Mark. Thank you.
Righto, thanks, Joe. A little bit of background on the research team involved in this. This is a project that began back in 2019, right at the beginning of the pandemic, which is a bit of a problem when we've got some pretty key collaborators working over in the US. So this project was developed in collaboration with Professor Derek Bailey out of New Mexico State and a master's student, Carolyn Wade. And the reason for that was that Derek is sort of globally recognised as a leader in understanding spatial landscape utilisation, particularly of cattle, where a lot of work's been done. But we intended to drag him and Carolyn over here for a few years to work with us on this particular project. As you might imagine, there was nobody travelling anywhere, and so this project was actually cut short just because we couldn't get them over here. Sorry, but we did manage to get a little bit of data, and it's probably well, I think it's worth exploring and showing you some of the general trends that we got. The reason we sort of set out to do the research was to understand how sheep and goats use that grazing landscape. There's actually lots done in cattle and a little bit in goats, but very little, sorry, a little bit in sheep, but very little in goats in terms of quantifying how they use that grazing landscape, and very little in our extensive sort of rangeland environment. And the reason that we're looking at that, a couple of things. One is to understand around this potential issue of, say, overgrazing and that sort of sustainability perspective, but also looking at the opportunities to actually do something that might optimize how we use the landscape. And so is there a way that we could place our water? Is there a way we can fence our country to better utilize the landscape? And that's why we sort of started off down this track. We're also just interested in looking at whether the technology itself could be of any value in a commercial context for day-to-day management of a property, or in measuring some of these sort of traits that you you don't actually you can't easily measure. So what do? We put out a bunch of GPS tracking devices, and these are pretty simple research grade devices. So they collect data on the collar. You've got to retrieve the collar to download the data, put them out on sheep and goats, a range of different animals from rangeland goats to Dorper sheep to the odd boar goat in there as well. And then we did a bunch of remote sensing survey work and field mapping of the properties on which we were working. I'm going to just go through one particular property, but just to show you that the raw data that we get back off this GPS tracking is just a bunch of dots on a map. And you can start to sort of see trends of how, animals are using the landscape, but it's pretty simple sort of stuff. And so what we do and what we've done in collaboration with the folks from New Mexico State Uni is go through a bunch of different analysis and start to look and understand a bit more detail about how these animals were using that landscape and what was driving that. And so here's one of the case study properties that we worked on just outside of Longreach. And this is for a bunch of multiple goats over a 3 or 4 month period over summer. And looking at the landscape utilisation. So you can see this map, the darker red areas are the areas that they used more, and the lighter areas are the areas that they didn't use very much. And almost instantly you can see there's a couple of dams and a bore drain, and you can see that distribution is, really impacted by, their association with water. And that's no big surprise. Everybody sort of knows that. But there's some little nuances and details in this as we go through, you'll see, that become quite interesting. So how do they, well, one of the key questions we had was in the paddocks where we were tracking both sheep and goats together, how do they use the country? Do they use it differently? And to start with, we sort of thought, well, yeah, there are some sort of differences there. You can see the sheep on the left, the purple, has a pretty wide range in grazing distribution over the period of time. And the goat has a pretty limited sort of grazing distribution or area utilisation over that period of time. But when you actually sort of start digging into it, what you find is that the goats have their own little unique territories in this particular situation. And they sort of move in their own little domains, whereas the sheep really broadly sort of use an area in a large scale sort of way. This is all of the sheep tracked over the whole period of time and all of the goats. And so the take-home message just here was that they're actually using a fairly similar range, but, which is an interesting little insight that I hadn't sort of really expected. We go to that next one, Joe. Righto. So I guess one of the other things that we were particularly interested in was some of these key movement metrics. And so this is about taking those dots on the map and actually turning it into useful data. Joe, if you can flick that over. And so what we wanted to understand was some key things around how far these animals were actually moving in the landscape and how that related, in this case, to water. And so just over a couple of different deployments, the minimum that our animals were moving, 5 kilometres a day on average for goats and 8.1 kilometres for some merino ewes. Maximum distance, the rangeland goats are only moving 6.5 kilometres in a day, but the sheep were really out there walking in some situations up to 20 kilometres a day. And so there's a pretty substantial energy expenditure in that. One of the key things that we were interested in was how far out they were going to move from water. And really the maximum that they were grazing out was around about that 2.5 kilometre, which equates to what the very limited amount of data that's out there around recommendations suggests. That's as far as they go, but really they wanted to be more like within about 500 metres to 1 kilometre of water is where they really preferred to be. Obviously, that's really dependent on the feed available to them. Joe? So what we also did was take a look at a whole bunch of other factors that influence grazing distribution, not just water. And all I want to highlight in this is that we looked at things like distance from trees, how many trees there were in the little area, the wind distance from the eastern boundary, so that tendency for animals to graze into the wind, and then bare ground cover, green cover, total standing biomass using the remote sensing satellite systems. And what we found is essentially, particularly for goats, is that all of those things were driving how the animals were using the landscape. But it was changing a little bit from year to year. So it wasn't exactly static. And so there was some variation there with particularly the feed base thing. And Joe, I'll just grab that next one. Where we were sort of heading with that, and this is as far as we sort of got, is we wanted to start to try and predict goat distribution. And so behind this map is that data that you just saw, and it's about generating a prediction of the likely utilisation of where these animals will graze according to the resources that are available to them. So that can be the feed base, the tree shade, and the water. And so this is sort of where we got to, that we were developing these prediction maps that allowed us to understand where they were likely, which parts of the landscape they were likely to use. The next step on from this that we didn't quite get there was to start to play around and put simulated water points in different spots. And so, for example, you can see that paddock there, that property there, that top left-hand corner gets very little utilisation. What happens if we put a water point up the top there? How much more country can we utilise? And so that's as far as we sort of got in this particular project. And there's a bit of an opportunity there to develop it on from there. I guess the other thing that we were interested in too is how could this data be useful in a commercial situation? So we did this with research grade devices, but now, particularly for cattle, we're starting to see the advent of these real-time tracking systems. And so we've got a couple of them running here at the moment on cattle. We've been trialling them on sheep, not so much on goats yet. There is some challenges in that a lot of them are based on ear tags, which are a little bit too heavy, at least to go into the ear of a sheep or a goat, we think, at the moment. But there's potential for them to go into collars. And, you know, one of the things that we were testing out in this project was how well a collar would stay on a goat. Now, putting a collar on a billy goat is just that they just tear those things off in seconds. But for any other goat, they will actually retain a collar reasonably well. They don't cause too many problems. And so going forward, there could be potential to actually have this data coming back to you as a producer in real time. And of course, there's a whole heap of basic applications. So things like, we're looking at stuff like stock theft detection, or have those animals been able to get in to have a drink using these sort of sensors. But, you know, ultimately, at the end of the day, you'll be able to get this sort of grazing distribution data in real time or near real time, or a summary at the end of the week or the month or the year, to allow you to understand how the animals are working in your particular environment on your particular property, and then potentially start to ask some questions about, oh, I wonder if we, you know, where should we put a water point? Where should we invest that sort of resource, or how do we fence that particular paddock to make the most of them? Might just click on Joe if that's all right. So just, I guess, a quick recap. Each property that we were tracking on was very unique in terms of how the animals use the landscape because of the resources available to them. And each property owner got a different bit of insight out of the tracking information. And so it's obviously very dependent on where you are in terms of the results that you get out of this. I guess one of the very broad sort of sweeping statements is, you know, that maximum distance to water recommendation around, you know, 2.5 kilometres is probably right, but it's probably the maximum, and it might be more efficient to have them closer on your place. That's a bit of work that we need to get into and do a bit more research on to understand, well, what's the value proposition for that, to have those waters closer. And I guess that at the end of the day, that, you know, the producers that we work with could see the potential value for this sort of data as a commercial tool. Just like I said, we've still got a few things to sort out before we can get it working on goats, but there's a lot of potential there. Last slide, I think, Joe. So in terms of some of the future research that we're looking at, we've hopefully got another student coming over from Oklahoma. She's applied for a Fulbright scholarship to come and actually look at what these animals are eating, where they're going. And Les is going to talk about that in a bit more detail, but looking at using some new technology, some fecal DNA technology to measure that. That's something that we're quite interested in. And Simon Quigley from Seeker University, who's done a bit of work in goats already. We're also just waiting to hear back about a project we've got in review, looking at really, I guess, ramping up some of this work we've done and some other research in terms of managing goats through drought and that grazing management. And that's a pretty significant investment if that comes through. Obviously, there's a good chance it won't. That's what we do as researchers. We put these things in and hope. But if we get that up, there'll be a really good body of research in this particular area, and opportunities for you guys as producers to potentially get involved and participate in that research if you're keen. So feel free to reach out and stay in touch. Yeah, that's me.
Thanks very much, Mark. Great presentation. Glad the IT just about hung on for us there. There are a couple of questions for you in the Q&A box if you want to have a look, Mark, and encourage any of our participants to keep adding those in as we go through. So our next speaker is Lester Paul. Lester is a Principal Research Scientist at Queensland Department of Agriculture and Fisheries and has been for almost 30 years. His main work areas have been in extensive grazing systems in the southwest of Queensland, in Queensland's southwest rangelands, and particularly in terms of looking at total grazing pressure. So Lester also does bioeconomic modelling of the costs and benefits of different herd and grazing land management practices. And Lester's going to talk to us today about the grazing preferences of different animals in the landscape. So, sorry, Lester, I think I dropped out there. Can you access the screen?
Yes, I can see that now, so thank you very much. Good evening, everyone. So I'll just have to move something here on the screen. But what I'm talking to you about tonight is based on a couple of papers that I published a couple of years ago. So if you're interested in getting into the detail, then I'm happy to send you copies of these because you probably can't get them off the internet, but particularly what all these different animals eat and where they graze. So what I'm talking to you about tonight is essentially a summary of lots of studies that have been undertaken across the rangelands in Australia. And so I'm hoping that what I present tonight on how much, what and where these animals eat and where goats eat in particular has implications for things like the sustainability, productivity, efficiency of production of goats grazing, foraging on their own, and goats in multi-species grazing systems. So I'm hoping that what I present will sort of help a bit in understanding the implications of what these animals do. So how much do they eat? And there's been hundreds of studies where under controlled conditions, people have fed lucerne grass or straw to these different species and measured how much they eat each day. And the benchmark that I am using to compare the intakes of these different species is the good old dry sheep equivalent. And in this case, it's a 50 kilogram merino wether or dry ewe at maintenance. And they're eating about 0.9 of a kilogram of dry matter a day. If you were thinking about fresh material, then it'd be 2 to 3 times that amount daily. So based on how much dry matter they eat daily, what's been measured under controlled conditions, a 50 kilogram goat is 1 DSE. So they eat about the same as a 50 kilogram sheep. A kangaroo, a 25 kilogram kangaroo, which is about the average size of a kangaroo in populations in Australia, they're approximately 0.5 of a DSE in terms of how much they eat daily. And a 450 kilogram steer, 1 AE, is about 8 DSE, and they're eating 7.3 kilograms of dry matter daily. But again, multiply that by 2 or 3 times for fresh amounts of feed. So what do goats, sheep, cattle and kangaroos eat in the rangelands? Again, there's been lots of studies. And I've emphasised here that the information I'm presenting on what they eat is for merino sheep in the rangelands. So it's not Dorpers or crossbreds, which are likely to have different diets to merinos. And And it was of feral goats. So a lot of these studies were done quite a long time ago when feral goats were more prevalent and there weren't many farm goats, rangeland goats. And so the studies were done on feral goats and what they eat. So herbivores, one thing is for certain, they eat the best of what's available to them. And the best plants are those that are highly digestible, nutritious, and non-toxic. And they tend to be the smaller plants and growing actively. Green is important, high in moisture content, high in protein content, low in fibre. And most of these plants are sitting in the pastures rather than up in trees. So the plants which are the most attractive, the most preferred, most nutritious are the annual forbs and the annual grasses. They tend to be fairly small and they come and go pretty quickly. And unless it rains at the right time, you won't see them. Perennial grasses, especially the green leaf of perennial grasses, is very attractive to all these animals, and it's very nutritious. But as they dry off and become stemmy, the forage quality deteriorates rapidly and substantially. Perennial forbs are very attractive to these animals. A lot of these animals when the pasture land dries out. So particularly if they're growing, actively growing, and they've got new leaves and stems on them, and the ctenopods like saltbush are very attractive to a lot of these animals. Usually when it gets tough, when conditions are pretty poor, then they're eating browse off the largest shrubs and trees. And if it gets really tough, litter lying on the ground can be quite attractive, particularly if it's green or if it's flowers or fruits. But if they're all gone, then just about anything lying on the ground will become attractive. And particularly goats will keep eating that stuff and to keep them alive. What do they prefer to eat? Well, it seems that sheep, cattle, goats, kangaroos have fairly similar preferences for the broad plant groups. But due to differences in their body sizes, the broad plant groups are not equally available to them. So if you look at these photos here, you'll see that the eastern grey kangaroo there and possibly the goat, they have, they're fairly small animals. They have a fairly narrow mouth, and they're able to select small plant parts and sparsely distributed plants and do pretty well on that. And then sheep are bigger animals generally. They have broader mouths. And then, of course, you go to cattle, which are much bigger and much broader mouths. Their ability to select nutritious plant parts and small plants in the landscape is quite reduced compared to these other animals. So that has a big impact on what is available to them. So what do they actually eat? We know what they prefer, but what do they actually eat? And there is great variation in what these animals eat from one place to another. And I mean that for individual species like goats or like sheep. You look at the studies that have been done of sheep or goats at various places at various times, there can be great variation in what they're eating. So one study or one sort of set of observations doesn't necessarily tell you what they're eating. And this largely depends on what's available, which depends on the land type, what it can grow, what it does grow, depends on the climate, and again, the size of the herbivore. So there is vast variation across Australia, but there are some trends which might help you understand something about the similarities and differences of these animals. But when it comes down to it, I think you need to look closely over time at what these animals are doing in your paddocks, where they're foraging, what they appear to be eating. And in doing that, you'll be miles ahead of someone like myself who just knows what they eat generally across Australia. So the trends. So here I'll just summarise quite briefly what these animals eat in good seasons and poor seasons on average. And I've got a picture there of a red kangaroo, but I'm talking about kangaroos generally. although red kangaroos have a diet that's much more similar to sheep than this would be for the grey kangaroos, which tend to, and wallaroos, which tend to eat a lot more grass, and cattle and goats. So in a good season, kangaroos predominantly eat grass, and it'll be predominantly the green leaf and the shoots of perennial grasses. But if there's annual grasses or annual forbs present, abundant, then they'll eat a lot of those as well. Sheep are similar in a way, except that they focus less on grass. They're going to focus more on the annuals, and they'll probably eat some leaf of the perennial forbs, like saltbush, for example. Cattle are somewhat similar to sheep, but they tend to eat a lot more grass in those good seasons. The annuals are small plants, and they're just generally not available to cattle in the quantities that they need. And so they tend to eat more grass, and they'll probably be eating some of the perennial forbs also. So, and I can't see that on my screen, but I think I know what's there. So with the goats, they've got a much broader diet. And so they do eat a lot of annual grasses and annual forbs, particularly when they're abundant, when they're available. They also quite happy to eat the green leaves of perennial grasses, and they're quite happy to eat the forbs, sorry, the foliage of perennial forbs, and at any time they'll have a fair bit of browse in their diets as well. If you go to a poor season, the kangaroos stick with the grass because they're very good at finding the green leaf and green shoots in that grass, so they can continue to keep eating grass while the other animals give up. And but as that grass runs out, they'll eat more and more of those perennial forbs like saltbush. The sheep, they end up eating less grass because it's not as attractive to them. They don't like the dry grass, and so they'll focus a lot more on the perennial forbs and on the browse. And the drier it gets, the more of the browse that they will eat. And pretty much the same for cattle. As the grass dries off and starts to run out and deteriorates in quality, the cattle give up on that because they can't select the green component of that grass that they need, so that they move on to something that's still pretty good nutritionally and more abundant, so they can consume a large amount each day. And the goats, well, they move pretty extensively to browse in those fall seasons, and for goats, when it gets really dry, and also cattle and sheep, no doubt as well, if it's drought, and there's very little to nothing on the ground layer, we know that they're going to live entirely off browse. And goats can go a step further and probably live for a reasonable time, make a living off dry materials that are lying on the ground. Where do they forage? Well, they don't tend to forage together at any one time, but over time, their foraging areas do tend to overlap. So I tried to be a little bit artistic and drew this up. I hope it helps. But in a wet period and wet times, kangaroos, they prefer the timbered areas, and so do goats. They seem to prefer the timbered areas, and especially where it's hilly. And they like the cover, I think. They like the protection it gives them, and they stay there as long as there's water and as long as there's pasture under the trees or nearby. And they're a bit reluctant to move out of those areas, and particularly the roos. But as it gets really dry, they will move to the more open areas where there's more pasture. I mean, it's probably not very good quality, but it's something, and they're forced to make that shift. The cattle and the sheep are pretty much just the opposite. They prefer the open areas, and they graze quite happily, forage quite happy in the open areas when it's wet, and stay there as long as they can. And when they get desperate, they'll move into the timbered country in search of browse. So the main points on what, how much, where they eat, kilogram for kilogram with these animals, they eat similar amounts of feed each day. There's probably slight differences. Kangaroos might eat a little bit less kilogram per kilogram, but but they're pretty much the same. In any one season, at any one place, they tend to eat different plants in different places. Like in any one paddock, at any one time, they probably are foraging in different parts of the paddock and eating different plants. But as conditions deteriorate and feed starts to run out, they move around, and what and where they eat overlaps considerably. So they end up, eating and foraging in similar places. So just end up with a couple of slides, one on goats on their own. Well, just some thoughts I have. Well, I know in southwest Queensland where there's a lot of dogs, they require expensive fencing, exclusion fencing to keep the dingoes out and keep the goats in. And if you want to keep them in paddocks, well, you're going to have mesh fencing in the paddocks as well. So there's a lot of money in that. The broad diet spreads their grazing pressure across the plant groups, and I think that's a good thing. They're not focusing on grass or browse all the time. They spread their grazing pressure across the paddock, so given enough time, so that's a good thing. And they're very well adapted to the rangelands. They have high selective foraging ability, so they're able to find the best plants that are out there. And the best parts of those plants. They have broad diets, so they're not restricted. They're very energetic in their foraging behaviour. They have a low daily intake, so they don't need to eat large quantities of readily available forages like cattle do. So they do thrive in good seasons, and they are very, very good at surviving in droughts. But that persistence, I suppose, the downside of that is that it maintains grazing pressure. And that can do some damage if the stocking rates are not managed. They play an important role in suppressing woody regrowth, at least of some plant species. So in the southwest Queensland, mulga in particular. And another really big advantage of goats is that over many decades, a genotype has emerged that's adapted to the rangelands. And they had to survive on their own in spite of, droughts and a lot of hunting and dogs and parasites, you name it. They've survived, and they're very productive and very good survivors. Goats in multi-species grazing systems. Well, a lot to work out in relation to this. But there's a lot of potential for multi-species grazing to reduce risks associated with market and climate variability, because as we know, prices for individual animals varies markedly over time. And so does the climate. So, there's potential here to focus on an animal that is going to give you better returns under certain conditions. But I suppose the trade-off here is that there's likely to be an increase in the costs and complexity of producing red meat. I guess it's going to require more infrastructure in terms of fencing and yards than you would have had with a single species. And I suspect there's going to be a lot more mustering and handling of animals that you wouldn't have had with a single species system. So the costs and the amount of work will go up. Red meat production in terms of kilograms per hectare per season may often be higher with multi-species grazing, because at any one time you have a number of different species utilising all the resources in a paddock. And so there's potential for that to be higher. But the downside might be you run out of forage more quickly in the dry times, because with that multi-species grazing, animals like goats and cattle together, may remove some of the haystacks that you might have wanted during the drier times. And I leaned on this. Now, I've seen a few mentions of this. People that talk to, or people that have written things, say that getting stocking rate is not rocket science. Getting stocking rate right is not rocket science. And some of those people are saying, it's not that hard. We know what we should be doing, and we know how to do it. So, it's not rocket science. But others say, it's not rocket science. It's much more difficult than that. And And I think multi-species, and I agree, getting your stocking rates right over long time periods is very, very difficult. Lots of balls in the air that you've got to try and juggle, and they don't necessarily fall where you want them to fall, and you can't predict where they're going to fall. So, and I think with multi-species grazing, it's going to be more highly geared, and therefore, probably a bit more complex and a bit more difficult to get it right as well. So thank you very much.
Thanks very much for that, Lester. A lot to think about there, and I think there's a couple of questions for you in the Q&A function, and encourage others to keep adding those in there as we go through. So our next speaker this evening is Peter Whipp. So Peter runs a Wagyu beef and goat grazing enterprise over 3 properties at Longreach, Armourmac with his family, and has a background in rural business consultancy and has researched vegetation management, farm profitability and efficiency throughout the Central West. He spent the last 25 years assisting producers across the region to implement business management, planning and to improve on-farm profitability and efficiency. Peter sees the potential in the outback both from a business and a community perspective, and is a passionate advocate for mental and allied health services in the bush as part of building a healthy, resilient community. He is the chair of the Outback Futures, a community-driven mental health not-for-profit with a staff of over 40 staff. Peter's core values are centered around making a difference and realizing the potential, whether that's in the community, in the people, on the land, or within the business. So Peter's going to talk to us about his experiences moving into a goat enterprise. Over to you, Peter.
Thanks, Joe. That's great. Yeah, look, and I might be the least likely goat producer to actually talk on here, but anyway, we'll see how we go. Our background, as you mentioned, was in ag consulting, and then we moved into cattle production. And the place that we're talking about tonight, we bought in 2011, and primarily as a beef breeding and growing property. It's ranges from sort of open Mitchell grass, or sort of lightly shaded Mitchell grass downs, through to well shaded, and then some pretty thick timber along a lot of water courses. So yeah, as I said, we bought that as a cattle operation. Even back then, there was feral goats that were fairly nomadic. They'd sort of seem to turn up at our place about July, August every year, and myself and my boys would go and grab whatever ones we could as they went past. And I think we were getting about $1 a kilo at that stage, so $30 to $35 a goat was pretty good money back then. And yeah, and we didn't have much thought about anything else. There was plenty of feed around back then, and yeah, but drought hit us pretty hard from 2015. We destocked completely in 2015 and really haven't restocked since fully. About 3/4 of the place remained very, very badly drought affected till last year, really. It's just we've had some good rain last year, and this year's probably the first wet season rain we've had for probably 8 or 9 years. So yeah, it is recovering. So what we noticed during that drought time, it was about the same time as feral fencing started to go up around our area, and we ended up with about 400 nannies and feral nannies just sort of fenced in, sort of accidentally, really, and we totally destocked the cattle. The cattle were all gone, and yeah, and really we just noticed over the course of the drought how well those goats performed, and they really hung, as Mark mentioned, in terms of, you know, goats camping in area. Well, those goats very much, they certainly weren't fenced in, but they camped in a little sort of area in the eastern end of our place, which at that stage had a feral fence on 3 sides of it. In theory, they could have just drifted out again, but they really camped there and stayed there pretty much the whole duration of the drought until we fenced them in. And yeah, and not only did they survive, but they actually thrived in that time. And yeah, really, I guess that was probably the first thing that caught our eye, was that, you know, they were surviving when we simply couldn't run one beast on the feed that we had or didn't have. And the other thing that we noticed was the impact on encroaching timber and thickening timber. Like, we've got quite a lot of gidgee that encroaches onto our downs country, and it thickens up in those sort of, you know, more shaded areas to a point where it becomes, or has become, a scrub in some places. And we'd spent quite a lot of money over the years thinning that, treating the encroachment where you could, when you still were able to do that. And as probably most people are aware now, that's become a much tougher gig to do these days. And yeah, anyway, so when we saw what the goats were doing with that encroaching vegetation and the thickening as well, we're really impressed, and it really sort of, I think the light bulb came on for us to say, well, you know, it was costing us, when we first started, I think it was costing about $15 an acre to treat that country with a bulldozer. And by the time we finished, it was up to nearly 25, and that probably same process would be close to 30 or might even be above $30 an acre now. And here we were with these goats that were doing, you know, not the same job, but doing a very effective job. And we were able to make a return off them in the middle of a drought when you know, there wasn't much return to be had anywhere else. So all of those things got us excited. But the thing, primarily for myself, I probably predominantly was a cattleman at this stage. But the thing that got me really excited, oh, hang on, there's that slide I probably should have had up there. So yeah, since once we got excited about those goats, we bought a few more, we fenced them in, we put Boer and Kalahari billies with them now, and yeah, we're pretty much running them as an enterprise. But just to really tell you why I'm excited about the timber control stuff. So this is a photo, an aerial photo from 1979. And if you just notice that dam in the sort of just to the right of the middle of the screen, because I'm going to show you another slide shortly. So 1979, timber encroachment had already started happening on our place. It's happened in the 50s. It started noticeably happening in the 50s. And then the 70s were another event, the 90s, and then the 2000s all had fairly big germination of Gidgee seedling growth where it had invaded into more open country. So if you just watch that, I'm going to go, that's that same dam there. There's a new dam there, but that's the dam we were looking at before. If you have a look at this area sort of to the left of that dam, I'll go back. So have a look at it there, and even out to the left of the screen there, where it's pretty much open or very lightly shaded downs country, and that's 1979, and that's the left hand side of that photo is 22, and I think the right hand side is about 15 or 18. The right hand side has been thinned, and the left hand side hasn't, and you can see the difference basically, and that's what got us excited about the goats in terms of what they actually did to open a lot of their country up, you know, legally and very cost effectively. And in fact, it was sort of, you know, cost positive rather than cost negative. So that's really where we started to see that they might be part of like part of our enterprise going forward, rather than just an opportunity thing that they had been in the past. Like our major concern, as you can see there, we were losing grassland and over a relatively short period, that was going to, you know, it was actually changing the whole biodiversity within those areas. So a lot of the old mature boree trees that were really good habitat trees were being killed out by the invasive Gidgee. And so yeah, from every aspect, it was a negative, from a production point of view, from a biodiversity point of view, from a management point of view, all negative. And we felt if we could do something that could turn that around cost effectively and within the constraints of regulations, yeah, we'd be really excited about it. So that was our, I guess that was our introduction and the reason we got into goats more and more. And yeah, so our strategy, I suppose, primarily our key income is cattle. Like, so we run Wagyu cattle over a couple of places, and that's our main, I guess, main bread and butter. And we didn't see goats as replacing that. Like we see them as, in some aspects, a tool that we use in the business to offset the impact of timber thickening, and also to act as a drought, I guess, a drought strategy. So we see that we could run a number of goats through the drought, even in the toughest drought that we've had. You know, we're probably able to run about 2,000 to 3,000 nannies through that time, which you know, has provided a pretty handy income through that period when there wasn't a lot of income from cattle off this place. So yeah, but because we're primarily a cattle operation, we didn't want to get hung up on, you know, a really complex management system that required a lot of time and a lot of effort. And so we pretty much worked out what we wanted to do. We wanted the goats to do, and we wanted how the goats would fit in with our normal operation. And so we had feral fenced by this stage, And we then started splitting our country up into, so we had a lot of, cattle fencing, so 3-barb, 4-barb, single hot wires, all that sort of, all our fencing was cattle fencing internally. So we started running netting and fencing our country into about 8,000 acre blocks roughly. So it might be, a number of 4 or 5 or 6 cattle paddocks, but with netting around the outside. So we would run our goats within those blocks and then rotate our goats on that sort of system. So we've been rotating cattle for a long time on a sort of smaller paddock size, but with our goats, we were determined just to try and run them in big blocks and only handle them twice a year if we could, and that's what we've got to. So we run them as a single mob. We run them in those around that 8,000 acre blocks. We muster them twice a year to handle, to wean billies and pull the billies out. So we pull out the breeding billies out for about 2.5 months, just to put a break in, so that when we're not handling nannies with little kids on them and all that sort of thing. We've all been there and done that and got the potties to show for it. So yeah, so that's what we do. Our focus with our breeding, we really only want to go to about a second cross boar or Kalahari red over our rangeland goat. I think it seems that that's going to retain enough of the good traits of the rangeland, with plus get us a little bit heavier carcass weight. We found, and I think Lester did mention, like infrastructure, well, for us is a key. Like we're pretty much cattle oriented. We got those sort of skills. We haven't really got goat handling skills other than chasing a few feral goats around in the past. And so we've, as I said, broken our country up with netting and just used a lot of netting on existing cattle fences. So just run netting on a 4-barb cattle fence, very quick to do. And I mean, it's still expensive to buy the netting, but it's a pretty quick process and fairly easy to do. And we find that makes it just changes the whole game. It makes handling goats a simple operation compared to, trying to manage them in a, massive, just normal sheep fences or cattle fences. Yeah, it changes the whole game and makes it easy to do. The other thing, we did all our troughs pretty much were cattle troughs. So, when we first started running goats, we were having, losses in the troughs and that sort of thing. And we thought about replacing all our concrete cattle troughs and looked at the expense of that. And anyway, we just come with the idea of putting concrete blocks in the troughs, and yeah, it really fixed that problem. So it makes it a little bit longer to clean, but yeah, it really works effectively, and we knocked all the losses out. Our yards, like that yard there, I don't know if you can really see that picture, but that's a pretty basic yard. The coolers are all netting, so just netting. There's a handful of panels there with a draft, and that's about it. I think we put a bit over 6,000 goats through those yards in November last year, and worked really well. Very happy. They've got a couple of holding paddocks around them, again, just netting. So in terms of cost, not a massive cost, but for what we were doing, it seemed to be really effective and worked really well for us. That's yeah, I guess it's interesting listening to what Mark said too about goats camping in areas. Like we've definitely found that. So we say we put them into a fresh 8,000 acre block of country, beautiful feed at one end, maybe some crappy gidgee scrub up the other end, and those goats will live in that gidgee scrub and just poke out of there, and they'll really camp in an area. And so what we're finding, or what we're thinking, is that we may have to split those blocks up again, just to get away from that idea of those goats camping in those same areas. They seem to really get to like one water and one area of grazing, and they'll just seem to work that really hard, and might be beautiful feed at another end of a paddock, what Mark mentioned, and yeah, they're not going there at all. So really interested in what he was talking about with the utilisation tracking on the goats there particularly. That's one thing we've learned, and just like following on from what Lester said too, like what we find. So as I said, about 3/4 of our place was pretty much smashed in the drought. The mitchell grass died out. We're concerned that we wouldn't get it back. And we're really only seeing mitchell grass seedlings coming back in the last 12 months. And, they're probably about, even in areas at the moment, only 6 to 8 inches high. So we're not stocking those paddocks at all with cattle because, I'm about 100% sure cattle would just annihilate those little seedlings pretty quickly. But we are stocking them with goats. And what we're finding is that that Mitchell grass is continuing to grow, even though the goats are grazing there, because they're spread out grazing almost everything else. It seems to be that, well, our experience anyway is when they're starting to nibble on the Mitchell grass, it's time for us to shift them. Like we know if we might have left them there too long, if they get to that stage, they'll nearly seem to select everything else first, and then eventually they just start to, you can notice them starting to make an impact on the Mitchell grass, and it's time to shift them. Well, it's probably time to shift them a month before. That's the other thing. And just one more slide, I think here. Because we like there's a couple of different approaches, I think, and I've had a few fellas talk to me differently about it. Like there's this idea that, you know, you can farm the invasive timber. Like, so you can say, well, look, you know, you got more woody weeds, goats love woody weeds, you just farm them and that's a good thing. And I think if you're a sheep, or like say a Dorper sheep person or a goat person primarily, I think that might be a pretty good strategy. But I guess, you know, we're probably more oriented towards our cattle, and we're probably very conscious of our biodiversity in our country. And I guess our strategy probably is to try and halt or not let it get any worse in terms of that invasive timber, and I'm not sure whether we'll be able to reverse it. I think in some places we might. Certainly in some holding paddocks we've been able to do that. But yeah, so I suppose there's those two ways of looking at it. You could say, well, you know, we might just farm just graze the woody weed or the invasive woody weeds lightly, and they're like a standing crop. Or you could do what we're doing and actually go a bit harder on them than that, and hope to actually pull them up. So that's now Georgia, my daughter-in-law, was going to be on tonight, but she's actually crook, so I'm sorry about that. But the point she wanted to bring up, she's got a paddock there, that a little paddock not far from the house, where she runs potties like at times in there. So it gets quite a lot of grazing pressure at times, and then other times none at all. And you know, she's her and her husband, she's married to my son, and they come back to the place about 2 years ago. So a lot of this is new for her, but she's really noticed things that I've sort of, you know, just gone over my head, and it's been really good to have them back in that space to say what Georgia noticed particularly was when she's grazing in this paddock. So it's a paddock that's got buffel grass, it's got timber, it's got a little bit of herbage and that sort of thing in it. Tiny bit of Mitchell grass. The goats will tend to, they'll definitely eat the buffel grass, but they'll tend to pull up on it at a pretty much, as I think Lester said, once it gets to about probably 15 centimetres, they'll pull up on that, and they won't go any harder on it. Whereas I know with cattle, certainly in roos, take it to the ground. But I guess that was the point she was going to just talk about tonight, was the fact that she's very confident from what she's seen that the goats are kinder to the grasses than say cattle or roos in particular, which is our other issue that we've had. So really, she would have probably presented that in a much better way, in a much more detailed way. But that was her main point that she wanted to mention tonight. So I think that's about everything I've got to say. I think. I guess the key thing for us is just that vegetation management. Like, we really want to try and address that, and we think we are doing that. And the other thing is the drought management side of things, so that next time, the next drought, when we destock again, which will happen, we'll still have a residual income there from those goats, which we'll be able to run for 2 to 3 years, we think, very successfully without damaging the country. Thank you.
Thanks very much, Peter. Great presentation. There's a couple of questions in the Q&A there for you, but I thought we might just ask one live, which is, why have you gone down the route of using netting fencing rather than hot wires?
Yeah, the good question. Yeah, and look, I've seen fellas here use hot wires quite successfully. Generally, though, with goats that are a bit more managed, so that they've sort of trained them to the wire, like, you know, they basically wean them on the hot wire and that sort of thing. We found the confidence that netting gives you when you're bringing a big mob of goats up, say, to a yard or something, and you know that they can't go through that fence. I think that's probably worth the expense. I mean, it is a big expense, and like it wasn't something we did lightly. We basically said we wanted the goats to pay for themselves, and so we budgeted to say, well, look, this is how much we're going to spend on fencing, and this is what the goats have to pay for within 3 years. And they've certainly, well, they've done more than that, but yeah, like just the confidence, you know, like we've used a lot of hot wires with our cattle, very happy with cattle, and we do wean all our cattle on hot wire, happy as Larry with hot wire, and certainly I wouldn't frown on it, but just the confidence with management. Yeah, it just when you're walking the goats up along, it just makes it so easy to know that you've got, it's like having, you know, 3 extra blokes on that side, you know.
Thanks very much, Peter. And there's just one other question for you there as well, which is more a sort of, if you brought unmanaged goats into the property in the past, how do you find they adapt to being more actively managed? Have you had any experience on that front?
Yeah, well, look, our experience, like we had those sort of, I think about 400 proper feral nannies, and they were full, like there was, I don't know how many, about 2 or 3, or we just as, not quite as many, about 200 feral billies, you know, the proper longhorns, you know, all they were proper feral little mob, and we sort of just cleaned them out, and then the only other ones we bought were pretty much, you know, we bought them off other people, but they were rangeland goats that had been, you know, they're only a shade ahead of being feral, I think. So, and they just fitted into our system really well. Again, like we only brought them into where we had that fencing done, and as we expanded our go-to, we just kept fencing. So, look, like we spent a lot of money on it, but I do not regret 1 cent that I spent on that netting, because it just saves, you know, like I talked to a lot of fellas, neighbours, whoever, and they all say, oh, how goats are hard to manage and goats are hard to handle and goats are hard to, and that just running that netting, no, changes it completely, changes the whole, it's a game changer. So, yeah.
Fantastic. All right. Thanks very much, Peter. I think there might be 1 or 2 more questions in the Q&A function there. Perhaps you can have a look at. So our next speaker is Associate Professor Matthew Harrison. Matthew is an award-winning scientist based at the Tasmanian Institute of Agriculture in Launceston. Matt is internationally renowned for his work in improving sustainability of agricultural and land use systems through innovative economic, environmental and social solutions to demand-driven problems. His team uses systems thinking, develop skills, technologies and practices aimed at improving food production, enterprise profitability, social license to operate and long-term agri-food sustainability. Matt also leads the Carbon Storage Partnership, a multidisciplinary initiative aimed at developing environmentally contextualized and socially acceptable pathways aimed at profitably progressing the entire Australian sector to net zero greenhouse gas emissions by 2030. And Matt's going to talk to us today about soil carbon in the rangelands. So over to you, Matt. Thanks very much.
Thanks, Joe, and sorry about that mouthful. So it was a good introduction, but I didn't realise it'd be such a mouthful. So sorry about that, and thanks for everyone for sticking around. I can see that most people have still stayed for the duration of the webinar, so that's really good, and thanks very much for your time. I was asked by Joe to talk about something a little bit different to what the other speakers have spoken about, which is carbon in the rangeland and sustainability more generally. And as Joe just mentioned, we do quite a lot of work on carbon, greenhouse gas emissions and the impacts of climate and climate change more generally on livestock systems. So there's probably 7 main messages that I really want to talk about tonight or this afternoon, wherever you are. The first one is that soil carbon markets tend to focus on permanence, but the short-term benefits of soil carbon offer the greatest fertility benefits. So what do I mean by that? So if you think about the soil carbon emissions reduction fund method or policy, you have to ensure that those practice changes result in soil carbon that stays out of the atmosphere for a minimum of 25 years, and the default is 100 years. So if you think of it, that's what's called permanence. But if you think about carbon that offers fertility, it's usually the short-term stuff that's quickly cycling. So that offers the greatest fertility benefits for plant growth and therefore productivity and therefore feed supply. So there's three forms of soil carbon in the soil, and I won't go into the details, but there's basically a fast pool that's cycling very quickly, a slow pool, which is sort of humus, and that can last up to 40 years in the soil. And then there's a stable pool, and that can last 500 to 1,000 years, and that's really derived from things like charcoal sort of thing. and it just sits there, but it's not very, it doesn't have any fertility benefits for plants. So there is important distinctions between those three carbon fractions, and although we segregate between them, it is really a continuum of everything from fast, labile to slow, resistant organic carbon. So as I said before, carbon markets tend to focus on permanence, and they have a contract period of 25 or 100 years. So the government's aspiration, or the market developer, or whoever it is really to pull carbon, atmospheric carbon out of the atmosphere and store it in the soil, and therefore reduce global warming. A farmer, as a business owner, has usually got the objective of being sustainable, of being productive, of being profitable. So the objectives are slightly different, and I'll talk about that towards the end. Resistant organic carbon, or ROC, has the longest benefit. It lasts the longest in the soil, but doesn't have as much benefit in terms of fertility. So if you think about a carbon market, if you're thinking about permanence, what you really need to do, and you want plant productivity, is build up that particulate organic carbon, the fast cycling pool, build it up and maintain it. So that's essentially what you would have to do to enroll in a soil carbon market. So what are typical soil organic carbon levels in Australia and elsewhere? If you think about desert and degraded soils, they're pretty low, and I'll talk about this shortly, but it follows long-term rainfall. So a very low soil organic carbon might be 0.5% or perhaps even less. Fire-derived forms of charcoal can be present in most soils, and you can get unweathered charcoal, so you can get soil organic carbon of up to 50%, although that's exceptional. Then you have things like peat soils and things, bogs and things that are permanently saturated, and they can have organic carbon above 50%. Again, they're exceptional. If you think about most arid soils in Australia, they're usually quite low, particularly in the rangelands. You might be looking at 0.5% and 0.5 to 1%. So just a slight lag in the line. So if you think about a high soil organic carbon, this is just a vertisol. And you can usually tell by the colour, the darker the soil is, the more organic carbon in it. So that's very high soil organic carbon, that's about 5%. And a low soil organic carbon might be a lighter, sandy soil, more friable. This one's actually a calcareous, but soil organic carbon between 0.5 and 1%, so very low. And really that soil organic carbon reflects long-term rainfall, which is the build-up of organic matter. Parts of that organic matter degrades, and you get sort of sugars from the plant roots, and you get bacteria working in the soil, and then that eventually goes to soil organic matter. But in the long term, it reflects fertility, management, and rainfall. The second main point that I wanted to make is that practices that improve soil organic carbon, regardless of whether or not you're in a soil carbon market, are to be encouraged. So it's generally a good thing to build up soil organic matter. Notice I'm talking about soil organic matter here, not soil organic carbon. So what are the benefits of improved soil organic matter? Well, there's lots. And when we talk about soil carbon markets, as well as other greenhouse gas emissions markets in Australia, that's called the Emissions Reduction Fund, but there are also many other voluntary markets that you can enrol in and get probably paid more. A 1% gain in soil organic carbon represents about 133 tonnes of CO2 equivalent. So it's a lot of CO2 taken out of the atmosphere. That's 133 tonnes per hectare. It's also drought resilient. So a 1% gain in soil organic carbon is an extra 144,000 litres. So it actually holds onto the water, and above a certain point, plants can extract that. Below a certain point, they can't, which is called plant wilting point. And it has all sorts of other benefits. So it has chemical benefits, physical benefits, and biological benefits for the bugs. Often what happens if you improve soil organic matter, you improve productivity, plant production, which is what I was sort of talking about at the start. If you improve plant productivity, you can generally improve profitability. So my team has shown that if the income from carbon at current carbon prices in Australia, which we did the analysis about $20 a tonne, which I think it's about 30 now, so the outcome wouldn't be that much different. The income from productivity gains is about an order of magnitude, or to times 10 more of a productivity gain associated with production as opposed to carbon. So you're better off focusing on interventions that improve productivity rather than focusing on income from carbon per se. So what changes or what interventions can you make to improve soil organic matter in the rangelands? Now, a lot of this depends on where you're starting at, and I'll talk about this in the next couple of slides. There's a number of different ways, but really what they come back to is improving seasonal ground cover. So think about anything you can do to improve seasonal ground cover. Now, obviously that's dependent on your management, it's dependent on the climate. So you can think about reducing stocking rates at the ends of the year or when particularly dry spells, reduce surface erosion if there's any potentially friable soils due to wind or water, increase pasture species diversity. And some people say improving pasture root depth may have some benefit for soil organic carbon. It does, but not a big effect relative to roots in the surface. Obviously reducing cultivation. Then they have, the Australian government has savanna burning methods, and they're really aimed at burning earlier in the dry season when it's cooler as opposed to later in the dry season when it's hotter and drier and the fires take off and burn more, sort of thing. There are other ways. So clay delving is another one in Western Australia in particular, where they have non-wetting soils. They invert the soil and mix that clay with the surface layer and therefore reduce the non-wetting sand, and the aim there is to improve productivity. But I'd encourage people to do a test strip before they go out and do large areas of that. And there's obviously other methods for carbon sequestration other than improving soil organic carbon in the rangelands. My view would be that rangeland revegetation, provided that it's beneficial vegetation, not as we've just heard from Peter. I'd say that revegetation, tree biomass, has probably got a greater potential for carbon sequestration relative to soil carbon sequestration in sort of extensive zones. So as Joe mentioned, we're based in Tasmania. There are other ways to think about improving soil carbon. So we're doing an experiment with feeding biochar to cattle. That's in northwestern Tasmania. And the idea there is that it reduces enteric methane, improves live weight gain, and can improve soil carbon. Now, it's undigestible, and so the more they eat, the more carbon they basically spread out. And so that does have an impact. And then there's a guy in WA who's done it for a long time, Doug Powell, and he's talking about dung beetles and whole improved ecology of the soil. They actually carry that biochar from the manure into the soil. So there's some strong evidence that biochar improves organic carbon. Its effects on live weight gain and enteric, we're not measuring enteric methane. We haven't seen any impact on live weight gain, so that remains to be seen. Obviously depends on what other amendments you put with the biochar, but really I raised this just to say that you can feed different forms of biochar to cattle. I do note though that we haven't tried it with goats, and goats are somewhat different to cattle, as we've heard tonight. So listen with caution, I guess. The third point was that soil carbon markets, or carbon markets in general, attempt to decouple climate from background effects from climate, which you can't change, from those in management. So if you look at long-term rainfall in Australia, it's pretty much the lowest in the centre, between 50 and 100 millimetres a year, and the highest around the edges. That's a very coarse generalisation. But that's based on a 100-year average. So if you look at Cairns, it's probably the highest in Australia, or Western Tasmania and Oodnadatta and Birdsville, somewhat lower. If you look at long-term soil organic carbon, and I'll just see if I can advance, where red is very low and blue and dark blue is very high, I've got a scale over in the bottom right-hand corner. It's about 5 tonnes of carbon per hectare in the centre, where rainfall is lowest, and up to 230 tonnes per hectare near the edges. Now, this is a continental scale mapping exercise, so it doesn't pick up paddock to paddock variability. But the point I really want to make is that in the long term and at the continental scale, soil carbon follows rainfall. So if I just go backwards and you look at where rainfall's lower and you look at where soil carbon's lower, and the same with where it's high, you can see that it pretty much follows long-term rainfall. So a question might be then, if I wanted to improve soil carbon on my particular farm, am I in a landscape that has low soil carbon relative to that in the surrounding landscape and therefore could be built up? So degraded paddocks or eroded paddocks have huge potential for improving soil carbon because they're starting from a low base. If you've kept it, if the environmental stewardship is high and you've kept ground cover maintained for the last 10 or 20 or 50 years, your scope for improving soil carbon might not be so good. The fourth point is that soil carbon is ephemeral, and that sort of relates to the previous point. I've taken this shot from Northern Victoria, but the principle applies anywhere. This was in October, and then 9 months later, you've had a 1% gain in soil carbon. That's entirely due to rainfall. It's not due to anything else. So it's going up and it's going down due to rainfall. The fifth point is that soil carbon permanence, for it to remain out of the atmosphere for at least 25 years or 100 years, whatever the market may be, your practice change has to be permanent. You can't make a change for 2 years and then say, well, I'll just go back to what I did before and then expect soil carbon will still keep going up. It won't. It'll go back to what it was. So if you think about a soil at time zero, it might be 1.2% organic carbon. There is an upper bound and a lower floor, it's called, or a lower equilibrium below which soil carbon can't go. And if you see that orange line, a typical paddock, soil carbon will go down in a drought and it'll go up in La Nina or a wet year. And so go down and go up in a typical sort of cyclical fashion or whenever you get droughts. If I was to continue adding nutrients or get rid of cultivation or reduce stocking rate seasonally so that the ground cover was maintained for a longer part of the season, soil carbon would go up, at least in that theoretical example. On the other hand, if you degraded it and you overgrazed it, or you had a heap of kangaroos that you couldn't control and they overgrazed it, your soil carbon would go down. On the other hand, you could build it up for a time and then you could stop doing that practice and it'll go down again. Probably the point though is that if you start off from a high soil carbon, and this is what most people tend to overlook, and there's so much contention and confusion over soil carbon, I think it's mainly because people don't measure or report where they start. So if you're starting near the top, near the 3 or 4 or 5%, well, you haven't got much to gain. And then people make a practice change and say, oh, it didn't have any effect. And that's usually because you're probably up near the top. Whereas if you start near the bottom, if you start from a degraded soil, you've got huge potential to improve soil carbon. So someone makes a practice change or changes to multi-pasture species or changes grazing management and they say, oh, I had a huge effect on soil carbon. Well, where were you at the start? A farmer in Alice Springs said to me that soil carbon markets make the good farmers bad and the bad farmers good. And by that, she meant if I've built my soil carbon up and organic matter over the last 50 years, so it's at a good state now and I enroll in the soil carbon market, I can't really go up much further. Whereas if I'm down the bottom, what's going to happen is that you've got huge scope for improvement. But if you're down the bottom, then that means you've probably let it degrade before you enroll in the soil carbon market. The sixth point is that climate change reduces the ability to sequester carbon. So we've, with MLA funding, we've been involved in a project called the Nexus project, and that's partners up the eastern seaboard of Australia and also in the west. And that's got a real focus on the impacts of extreme climatic events on livestock systems, as well as the opportunity to mitigate greenhouse gas emissions. And what we've shown is that climate change will reduce the potential to sequester carbon in soils. And those titles there are typical of newspapers, somewhat contentious sort of thing. But what they're really saying, they were based on our articles, what we found is that soil carbon sequestration, and sequestration is a rate of change, will go down between 55 and 133% by 2050. Now, that was for Tasmania, but the same principle applies. Global warming is consistent anywhere in the globe. So it doesn't matter where you are, the temperatures are going up, and you just have to look at the temperatures on the bureau to see that going up. The soils warm up, particularly near the surface, respiration heats up, and you tend to lose more carbon dioxide than is fixed. The other thing that's happening in the background is rainfall. Rainfall is very variable and noisy, and you sort of can't, it depends on where you are, depending on the trend, but inland Australia is forecast for more droughts sort of thing, so more extreme conditions, and droughts do reduce soil carbon. So, and it's important to think about climate change when enrolling in a soil carbon market, because the minimum period is 25 years and the maximum is 100 years. So the likelihood that the climate will change in that period is near certain. And the seventh point is about the difference in aspiration. So the government is thinking about reducing global warming, and the individual, as a farmer, as a business owner, tends to be thinking about their livelihood, intergenerational sustainability, profit, and everything else that they've got to think about. Not so much climate change, maybe think about climate change, but might be one particular consideration. And that really comes down to one part of the policy instrument, which is called additionality. Now, additionality means that the rate of change of soil carbon before I make a practice change is less than the rate of change of soil carbon after I make a practice change. So that means the extent to which I'm removing carbon out of the atmosphere is additional to what it would have been if I didn't make a practice change. And this comes back to the point about the Alice Springs farmer. So it's making the good farmers bad and the bad farmers good sort of thing. Farmers that have historically had good agricultural stewardship haven't really got much scope to improve, whereas farmers that have let it degrade probably have a lot of scope to improve and income to be gained by enrolling in a soil carbon market. So one way to get around additionality might be to make payments based on carbon stocks rather than carbon fluxes. A carbon flux is a change in soil carbon over time. A carbon stock is what's there today. And it's easier to measure, it's less variable. It's almost like a payment for environmental stewardship. How would that work? Well, that would have to be defined, but it could be based on, a percentile of what you are in your region. If you're, 75 or 85th percentile above what the carbon is for your region, then you get paid. If you fall below that level, you no longer get paid. It would be easier to measure. It would get rid of the issue of additionality. It would remunerate people who have historical good management practice, and it would essentially remove the contention associated with the point about additionality. This is my final slide, so thanks very much for sticking with it. Practices that improve soil organic matter are to be encouraged. At the continental scale, soil organic carbon tends to follow rainfall. Soil carbon can be easily lost, but it can be easily gained as well. Financial returns from soil carbon markets tend to vary widely. So some people I've spoken to have made big losses. Other people claim they've made a lot of income. The proceeds are tax deductible. So the costs associated with acquiring ACCUs are also tax deductible. And the point really that I made before about the productivity gains. So if you improve soil organic matter and you improve productivity, that tends to lead to greater profit as opposed to income from soil carbon per se. So really, whether soil carbon markets are science or snake oil depends on the motivations of the individual. So I'll stop there. Thanks very much, Joe.
Thanks very much, Matt. Very comprehensive presentation. Just a quick question for you from the pre-submissions is whether you have any thoughts on the relative emissions profile of a goat enterprise versus other ruminant enterprises.
Usually emissions of ruminant, as long as it's a ruminant enterprise, it really depends on animal numbers. Well, it really depends on DSE. So cattle have much higher emissions than sheep, but as Lester showed, one steer is worth about 8 sheep. So it's really based on animal numbers. I mean, if you had a similar sized wether to a goat, well, the emissions are probably similar. So I just think it's total animal numbers, Joe, rather than differences in ruminants sort of thing. If you're going into monogastrics and other sorts of things that are non-ruminants, well, that will have a big effect, but yeah.
Okay, thanks very much, Matt. Thanks very much, everybody, for dialing in this evening. I hope you found that really useful. We have put a post-webinar survey in the chat box. We'd really appreciate if you could have a look at that and provide some feedback on this evening's webinar and perhaps any additional topics that you'd like to hear more about in future. We also have the recently launched Goats Hub available through the MLA website, and that has a whole range of information and resources available on it. And we'll post the recording from tonight's webinar on that page as well. So thanks very much to all of our speakers. Some fantastic talks this evening. Really appreciate everybody taking the time to dial in. And if you've got any further questions, please feel free to get in touch either directly with myself or Melanie Smith as well. Thanks very much, everybody.